Hi everyone! In this video we're going to discuss how to combine probabilities using the words and or and the different aspects that go into that. We're going to start with and in order to talk about this we need to decide if the events that you're looking at combining are independent or dependent. If they're independent, that means that they don't affect one another in any way. So whatever happens first has nothing to do with what happens second and third and fourth and so on. If that is the case, then you combine them together by multiplying their individual probabilities. So if you're trying to figure out what the probability of A and B is, then all you have to do is multiply probability of A times the probability of B. So in the first example, what is the probability of rolling 3 6s in a row with a single die? Well, the other way of looking at this is they're asking us for the probability of a 6 and a 6 and a 6. And in this case, this is independent because when I roll the first die and I get a 6, I pick it back up and I roll it again, and it has nothing to do with what just happened, and there's no effect on what's going to happen next. So it's independent, so all I have to do is figure out what is the probability of rolling a 6 and then multiply that together 3 times. So the probability of rolling 1 6 is 1 out of 6 because there's 1 6 on a die and 6 sides total. So since I'm rolling it 3 times in a row, I just need to multiply 1 6 times itself 3 times, and then to figure this out I just multiplied it straight across. 1 times 1 times 1 and 6 times 6 times 6 gave me a probability of 1 over 216. For the next example, it says in one town 74% of adults have health insurance. What is the probability that 4 adults selected at random from the town all have health insurance? This is another situation where we're combining things together with the word and. What's the probability that adult 1 has health insurance and adult 2 has health insurance and adult 3 and adult 4? And since we're doing that and they are independent, we just have to multiply the probability that each one has health insurance, because the probability of one adult having health insurance has nothing to do with whether or not someone else does. So the probability of each one having health insurance is 74%. So in decimal form, that's 0.74. So since there's 4 of them, I'm multiplying 0.74 times itself 4 times. I got an answer of about 0.2998, which in decimal form is fine to leave as is. In percent form, that's about 30%. The next one asks, what is the probability that the next 4 births at a hospital are all girls? So they're asking for a girl and a girl and a girl and a girl. 4 total. This is independent because what happens in the first birth has nothing to do with what the next person's going to have. So you have a 1 out of 2 chance each time for having a girl. And since we're talking about 4 girls in a row, I multiplied it 4 times, which gave me 1 over 16. Okay, the other thing we need to account for now, if we're combining probabilities together with and, is if the events are dependent, meaning whatever happens first is going to affect what happens after that. If that's the case, you have to look a little bit deeper into the situation and account for what will happen second, third, and fourth. This will make a little bit more sense when we look at the examples. So let's take a look. It says a 3-person jury must be selected at random from a pool that has 6 men and 6 women. What is the probability of selecting an all-male jury? So we're trying to select 3 people from a pool of 12 people total, 6 men, 6 women. They want an all-male jury for this. The problem is, once we are done selecting the first person, that's going to affect what the probabilities of selecting the next 2 people for this jury. What I mean by that is, if we're going to select an all-male jury, there's 6 males to choose from out of 12 people total for the first person on this jury. But then someone gets picked. That only leaves 5 males out of 11 people total now for the second selection. And now 2 people are picked. Assuming that they are both male, now you only have 4 males left from the pool out of 10 people total. That's what I mean by you have to take into account what happens after the first selection when you're talking about dependent combinations of probability. So once I've got this all set up, then I multiplied it straight across, and I got 120 over 1320, which I then reduced to 1 over 11. Next says, what is the probability of drawing 3 aces in a row from a standard deck of cards? Here's another dependent situation, because once you draw one of the cards, now there will be less cards in the deck to choose from. So for the first card, I want to choose 3 aces. There's 4 aces in a deck total, and there's 52 cards altogether. So for the first card, if it's going to be an ace, I have a 4 out of 52 chance of picking an ace. Then, assuming that that first card is an ace, I go to choose the second card. Now there's only 3 aces left and 51 cards total. Then I choose another ace. Now for the third selection, I only have 2 aces left to choose from out of 50 cards total. Then I multiply that together. I got 24 over 132,600, and that reduced to 1 over 5,525. In this example, it says a box of candy contains 5 dark chocolates and 5 white chocolates. If you randomly pick and eat each candy after choosing it, what is the probability of choosing 2 dark chocolates and 1 white chocolate? Again, this is dependent because you're picking the chocolates out and then you're eating them. You're not putting them back. So what happens first is going to affect what happens after because there'll be less chocolate to choose from. So the first candy we're picking is going to be a dark chocolate. There's 5 dark chocolates altogether out of a total of 10 candies. So you have a 5 out of 10 chance of picking a dark chocolate. You pick it, you eat it. Now you pick the second candy. That's also dark chocolate. But you just ate one, so there's only 4 darks left out of 9 candies total. You eat that one. Now you pick the third one, and it's a white chocolate. You haven't picked any white yet, so all 5 are still in the bag, but there's only 8 candies total because you've already eaten 2. So that's how that one sets up. And then you multiply this all straight across. I got 100 over 720, which reduces to 5 over 36. Okay, on to the second type of probability combining, which is combining with OR. When you're looking at ORs, you have to decide first if they are overlapping or non-overlapping situations. If they're non-overlapping, it means they cannot occur together. They simply don't happen at the same time, like flipping a coin and getting heads or tails. You're going to get one or the other. You can't get them both at the same time. Those would be considered non-overlapping. If that is the case, to combine an OR, you add. So the probability of A or B is just the probability of the first thing plus the probability of the second thing. Suppose you roll a single die. What is the probability of rolling either a 2 or a 3? These are non-overlapping because if you roll one die, you're not going to get more than one number. So you can't have these two things happen at the same time. All we have to do then is figure out what is the probability of rolling a 2, and then add that to the probability of rolling a 3. If you roll one die, the probability of getting a 2 is 1/6. The probability of getting a 3 is also 1/6. Add that up. It's 2/6. Reduce it. Final answer is 1/3. In this problem, we're looking at a table with data. So this is a relative frequency probability question. We're going to combine information using this data. It says the results of a survey about marital status are displayed below. Suppose a person is selected at random from the table. What is the probability that the person selected is a married male or a single female? So we're combining it together with an or. We have married male or single female. Since those two things cannot occur at the same time, you can't be a married male and a single female at the same time, these are non-overlapping. So all we will need to do is figure out how many married males are represented in the table, how many single females are represented in the table, and just add up those probabilities. So for the married males, I found the intersection of those two categories, which is 64.7, and the single females represent 31.7. So I added those two up, and I'm putting it over the total for the entire table, which represents everybody that was surveyed. 64.7 plus 31.7 gave me 96.4 over 235.8. And then since I don't like to have probabilities that use decimal and fraction form at the same time, I divided this all the way through to get decimal form, which gave me about 0.4088. In percent form, that's about 41%. What is the probability of drawing either a red 6 or a black 8 from a standard deck of cards? We're combining this with or, so we need to decide, can we have these two things happen together? Can you have a red 6 and a black 8 happen at the same time? And no, you can't. So this is non-overlapping. We just have to decide how many ways can we choose a red 6 plus how many ways can you pick a black 8. If you look at a standard deck of cards, there are two red 6s. The red suits are diamonds and hearts. So you could have the 6 of diamonds or the 6 of hearts, plus black 8s are the clubs and the spades. So you could have the 8 of clubs or the 8 of spades. Add that up. It's 4 over 52. Reduce it. It's 1 over 13. Okay, last but not least, you could have overlapping events if you're talking about an or combination. An overlapping event is when the two things can happen at the same time. For example, in this picture, if you are choosing a queen or a club, there's 4 queens to choose from. There's 13 clubs to choose from, but there's the queen of clubs. That card falls into both categories. That would be considered an overlap. And when you combine these probabilities, you have to subtract the overlap out, or that card will be double counted. It will be counted twice. So, probability of the first thing happening plus the probability of the second thing happening minus any overlap that occurs. So what is the probability of drawing a 5 or a spade from a standard deck of cards? We need to figure out how many ways can we pick a 5, how many ways can we pick a spade, and what is the overlap? I'm going to need to subtract that out so we don't double count it. So in this picture here, you can see that there are 4 5s to pick from, and there are 13 spades altogether. One of these cards falls into both categories. It's a 5 and a spade. So we need to subtract out that one card so that we don't double count it. So 4 over 52 for the 5s, 13 over 52 for the spades, minus 1 over 52 for the overlap. That gives me 16 over 52, which is 4 over 13 as my final answer. Okay, looking at this table again, now we're going to look at it with an overlap. The results of a survey about marital status are displayed below. Suppose a person is selected at random from the table. What is the probability that the person selected is a male or a widow? Since we're combining this together with an or, we know we need to add this up. But in this case, you could have a male who is also a widow. So we're going to need to take out that overlap when we add this up. So for the males, all of these people here represent the males. The total for that is 114.5. Plus the widows, the male and the females here represent the widows. There's 2.7 widowed males and 11.2 widowed females. There's 13.9 altogether then. However, the 2.7 has been counted twice in all of this, so we got to make sure we take that out because that's an overlap. It's been circled twice. So when we add this up, it's 114.5 plus 13.9 minus the 2.7 that was counted twice. That gave me a total of 125.7 over 235.8. And then I divided that through to get about 0.533 in decimal form. In percent form, that's about 53%. Okay, so let's take a look at what this looks like. There are 12 face cards altogether. The Jack, the Queen, and the King from each deck is considered the face cards. There's also 13 diamonds in deck. There's 13 cards in every suit. So here's all your diamonds. That means that 3 of these cards fall into the overlap. They are face cards and they are diamonds. So we have to remove those. 12 plus the 13 minus 3 gave me 22 over 52. And then I reduced that to 11 over 26.